Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the new topic 1.5 entitled The Inverse Trigonometric Functions. So we already learned inverse function in Maths 1, where we have learned the definition of inverse function. F must be one-to-one function for it to be inverse. Okay, and you know that you can find inverse from the basic function here, y is equal to fx. So in order to find inverse, this is the inverse x here, so this will be f inverse y. Okay, and again, this is the condition. It must be one-to-one function, where we can evaluate it through horizontal line test. Only will touch at one point. Other than that, we have learned that the relationship between domain and range for f and f inverse. The domain of f is equal to range of f inverse, and the range of f is equal to domain f inverse. So using the theorem also, we can find out that the theorem on inverse function, we can find that f inverse, when you compose with f, x, the result will be this x here. Okay, and the condition is x must be inside the domain. And vice versa, if you do another way around, f composed with f inverse y, you'll get the answer y, with the condition y is within your range. Therefore, we'll use all of this theorem on inverse to apply it in inverse trigonometric function. So first of all, let's see for inverse sine. Okay, we know that this is the graph of sine, y equal to sine x. This is sinusoidal graph. What's the meaning of sinusoidal? Sinusoidal meaning that the graph is never ending from minus infinity until infinity. It will go down, up, and like this. So this definitely is not one-to-one function, because if you do horizontal line test, it will touch at more than one point, okay? So in order to make it to become one-to-one function, we need to restrict the domain. We want to cut from certain period to certain period for it to be one-to-one function. So for inverse sine, we will choose to cut from minus pi over 2 here until pi over 2. Okay, we want to only take this part here. So let's see the graph here, the restricted domain. If you transfer this graph here, this will be the graph. So why do we want to take from minus pi over 2 until pi over 2? Because when we restrict the domain, now this is one-to-one function. If you do a horizontal line test, it will touch only one. So if you want to see from a quadrant perspective, the graph can only take from minus pi over 2 until pi over 2 only. Okay, so from here to here only. So the only quadrant that is involved here is quadrant 1 and quadrant 4 only. So if your sign is positive, definitely you are in quadrant 1. And for quadrant 4, this is the house of cos. So when your sign is negative, definitely your quadrant is in quadrant 4. So let's see the definition here. Y is equal to sine x. This is one-to-one function. The domain, the new domain, is from minus pi over 2 included until pi over 2 included. While your range didn't change, it will still be from minus 1 included until 1. Can make inverse sine. Since this is already one-to-one function, we just flip the graph like this. The x-axis here now will be y-axis. The y-axis here now will be x-axis, because this has been reflected about the line y equal to x. So now this is the new definition of inverse function that you need to take care of. Okay, so the new domain is y from minus 1 included until 1. Range is from minus pi over 2 included until pi over 2. Meaning that we just exchange the domain and range for the function of y equal to sine x to be the domain and range for inverse sine. The properties of inverse sine we can also use here. Inverse sine x composed with sine x, the answer will be x. Okay, with the condition x must be within the domain. So let's look at the domain. What is the domain? X here belongs to your sine. So domain for sine is from minus pi over 2 until pi over 2. Now let's see another one here. Sine composed inverse sine x is equal to x. Okay, with the condition your domain here, x here, must be within the domain. So let's see here, x here stands for, so x here, the domain is for inverse sine. So domain for inverse sine, it must be from -1 included until. So that is how you want to find out what is your domain. Now let's apply the formula here. The first question asks us for inverse sine 0. So how should you solve this? So first of all, when you see inverse function, straight away we let another variable to be inverse. Okay, so for example, we choose y, let y equal to inverse sine 0. So now let's put this in terms of sine. So sine of the opposite. Sine y is equal to, so you can take this value here, equal to 0. And be careful, the domain for y, because this is for sine, so domain for y, it must be between -π/2 until π/2 only. So now we need to take care of this y here. So what is the value of y? So that sine of that angle will be 0. So we know that sine 0 is equal to 0, right? Therefore, we can write y is equal to 0. So 0 is inside this domain here. So we can accept y is equal to 0. Therefore, we can write inverse sine 0 is equal to 0. So that's how you solve question for inverse sine. Now let's see another one. For B, inverse sine sec 3/2. So let's repeat the process just now. Let another variable to be inverse sine. So let y as inverse sine sec 3/2. Okay, so now let's find your sine. Use sine of the opposite one here. So sine y is equal to sec 3/2. Take this value here. Okay, and make sure your angle must be within the domain -π/2 until π/2. So let's find what is the value for y. So that sine of that angle will be sec 3/2. So we know that sine π/3. Okay, so sine π/3 will be sec 3/2. So π/3 is within quadrant 1 and quadrant 4. So that is your final answer. Let us simplify. The answer is π/3. Now let's see the next question. Inverse sine of -½ So again, let y as inverse sine of -½ and then let's write it as sine right now. Use the opposite side there. Sine y is equal to -. In order to check our answer, we must make sure the answer is within the domain. So here, I want to draw the quadrant for you so that you are clear. We know that it must be between -π/2 and π/2 only. So your graph must be only in quadrant 1 or quadrant 4 only. Okay, if your sign is positive, definitely you are acute angle, quadrant 1. But if your sign is negative, definitely you are in quadrant 4. Okay, so since y now is negative, so we know that our angle should be here. Okay, so let's find the reference angle. So at what angle the sine y will be half? Okay, so we know that sine π/6 is equal to half. So your reference angle here will be π/6. So in order to read your final answer, we need to read them in quadrant 4. Okay, you cannot read them like this as the positive angle because quadrant 2 and quadrant 3 does not exist in our current world right now. Okay, you only allowed to be in quadrant 1 or quadrant 4. So the only way to read this quadrant 4 is you need to take the negative angle. Go back from 0 towards your clockwise. Okay, so let's read our answer. Therefore, our answer will be -π/6. pi over 6. Now let's see the next example, inverse sine 5. So inverse sine 5, be careful, if you look at this function here, inverse sine 5, the domain for inverse sine that you need to take care of is from -1 until 1. Okay, but 5 now is definitely above 1, so that this one here is undefined.